So what a logarithm is, if you want an informal definition that everybody can understand, a logarithm is really like an exponent. Remember the very first problem I did when I introduced this to you? I think it was log base 3 of 9. Log base 3 of 9. And you remember what the answer was? 3 to the what power equals 9? 3 to the second power is 9, right? So in other words, when we say, what is the log of 9 to the base 3, we're saying, what is the power? What is the power? What is the exponent? The exponent would be, of course, 2, right? What is the exponent? The exponent is 2. So a logarithm is like an exponent. And what we're going to have to do to prove the laws of logarithms, we're really going to be using the laws of exponents. If you can keep that in mind, that a logarithm is like an exponent. So if I have, what was the law of exponent? What is it when you multiply? When you multiply with the same base number, you do what to the exponents? When you multiply, you add exponents, right? When you multiply with the same base number, you add exponents. When you multiply here, you add logarithms. You add exponents. Exponents are like logarithms, right? So it makes sense that when you multiply, you add logarithms, just like when you multiply, you add exponents. And I'm trying to give you that sort of an informal sense of this. Now, to be perfectly up to snuff on this thing, we need to prove it mathematically, but I'm not going to take time to do that right here. The mathematical proof is in the book on the first page. So now, I think what's really important now is that you get a sense of this and get an idea of how to use this. Here's what the property says. The log base b of mn of a product of two numbers is equal to the log base b of the first plus the log base b of the second. And what that says in the first law of logarithms is when you multiply, you add logarithms. When you multiply, you add logarithms. All right? Now, if when you multiply, you add logarithms, what do you suppose you're going to do when you divide? I love this. Log base b of m over n. If when you multiply, you add logarithms, then when you divide, you're going to subtract the logarithms, right?
What did you say?
If when you multiply, you add logarithms, then when you divide, you must subtract the logarithms. So it's going to be log base b of m minus log base b of n. Whoops, I'm supposed to be doing that in green. All right? In fact, wouldn't it be neat if I did that in pink? Let's ham it up a little bit here for the camera. All right? All right? Log of a product, you add logarithms. Log of a quotient, you subtract the logarithms. Okay? Now, the next thing I want to do is, suppose I had another property here that says log base b of m and m. Log of m and m. What would be the log of m and m? It's a product, isn't it? So what would you write? Log base b of m plus log base b of m. Hey, those are exactly the same, aren't they? So what do you have? 2, right? So that would equal 2 log base b of m. Now, let me write that another way. Instead of m and m, what should I have written mathematically? I mean, I didn't mean to insult you by writing m and m, but we should have written that as log base b of what? M squared. Okay? Because it's m times m, which is m squared. Let's carry that one step farther. What if I asked you to give me the log of m times m times m? The log of a product of m times m times m. What would you end up with for each one of those? Now you got 3 of them, don't you? 3 factors, so you'd have to log base b of m plus log base b of m plus what? Log base b of m. Which would be a total of how much? 3. 3 log base b of m. Isn't that right? 3 of them? And how could you write this instead of writing it log m. That would be the log base b of m cubed. Okay? Now this is a strange looking property. This is going to take some getting used to. 3 can be, the 3 for the exponent can be brought down and thought of as the coefficient of log base b of m. Log of m to the third is 3 times the log base b of m. Now in general, what would it be? If I had, let's say, a generalization, this will be a good place to do it, I guess. This is going to be the third law. Log base b of m raised to the n power. What would you have? What can I do with this? It becomes like n times what? The log base b of m. Okay? So here are the 3 laws of logarithms. Here is, let me get a new piece of new color. Law number 1, when you multiply, you add logarithms. Law number 2, when you divide, you subtract logarithms. And law number 3, when you have m to the power, then you multiply by the exponent. Remember the law when you have a power raised to a power, what's the rule? You multiply the exponents? Yeah? Remember that? The law of exponents, when you have a base number and a power raised to a power, then what you have is you multiply the exponent. So we're going to multiply n times the log base b of m. That's the third law. All right, now there's some applications of those that are interesting. And let me get into those applications. I think maybe I better leave this up here for now. So let me come over here and do, I've got 4 specific applications of that. What would you do if you had the log base b of the square root of x? How in the world is that going to apply to one of these laws? We don't have anything here about square root of x, do we? What is the square root of x? Can you write that a different way? In other words, no, I didn't mean to erase that. I want to write that as the log base b of, instead of writing it square root of x, let's write it x raised to the 1/2 power. Now you see you have a power. So what do we do with the power? Use the laws of logarithms. You've got a 1/2 log base b of x. Okay? In other words, this power comes down, becomes the coefficient. Strange, isn't it?
Very much.
That's why it's going to take practice. That's why you may need to go over this a time or two, you know. This isn't just going, this is logarithms. This is heavy-duty stuff. This isn't going to just jump out at you. I don't think. If it does, let me know. All right? It didn't jump out at me, let me tell you that. All right? Second application is, what would it be if I had the log base b of the cube root of x? It would be x to the 1/3, wouldn't it? Do you see that? This would be log base b of x raised to the 1/3 power, which would be the 1/3 log base b of x. Right?
The second step's real logical, and then when you leap to the third one, it's kind of like a leap of faith.
What, here?
Yeah.
The 1/3. Right. Well, that's where you take the power and you multiply by the power. The 1/3 power, x to the 1/3 power, the log of x to the 1/3 power is 1/3 log base b of x. That's the one you're going to have to get used to.
Now we're set up, and then there's someplace you go after that.
Yeah, well, that's all we're going to do for now.
Just set up.
Yeah, we're just getting used to this. Okay? Now, the third application, I wanted to generalize this and say, instead of having the cube root of x, what would I do to generalize that? Let's say we have the nth root of x. The nth root of x would be x to the what? 1/n. Okay? And then how does that change my answer? Instead of 1/3, now I have what? 1/n. Okay? 1 over n. So in other words, the log base b of the nth root of x would be 1 over n times the log base b of x. Isn't that a strange looking thing? Okay?
So if we went further to set it up, we'd be saying b raised to the 1n power equals x.
No.
After we
No, I don't want to do that.
Oh.
I don't want to do that right now. Save that thought. Okay.
Okay.
All right, now, there's one more application I want to talk about, and that is, what would you do if you had the log base b of 1 over x? 1 over x. What is 1 over x? Can you write that as a power? You could write that as log base b of, now, 1 over x is actually x raised to the negative 1 power, isn't it? X raised to the negative 1 power. Now what that means negative 1 times the log base b of x. Negative 1 times the log base b of x. You see, this negative 1 power becomes negative 1 times the log base b of x. In other words, you don't have to write negative 1, do you? What could you write? Negative log base b of x. Negative log base b of x. How about that? Isn't that strange? Log base b of 1 over x is the same as negative log base b of x. Okay? Now, I'm throwing some new things out at you here, and they may not all come home to you right away, but let's practice a problem or two to show you exactly what I want you to do with this. And this assignment is...
Erase the center.
What?
Can you just erase the center?
Yeah.
Thank you.
Yes. Okay. This is going to be somewhat of a mechanical section.
Thank you.
You may be wondering what good is all of this stuff, and you're hanging in there with me. You got to learn this before you can learn what good it is. Did I mention applications? Man, there's some great applications of logarithms. There's some really good applications, but to be able to understand the applications, you have to understand the laws of logarithms and be able to work with them. So that's what we have to do today, learn the laws of logarithms, and I'll be able to get you to maybe one application of it. Let me do a problem, number 2. Number 2 in section 4.03, and number 2 says log base b of x to the 4th, z to the 9th. Okay? Now, for whatever reason I may have in mind, what I want you to do is take this and break it down. Break it down. I want you to break this down. This is actually on page 19 of this section for now. I hesitate to mention page numbers because I'm planning to change the page numbers. So if you're looking at this later, it may not be page 19, but for right now it's page 19. All right, now, do you see that that's a log of a product? It's a log of a product. Now, what's the deal on the log of a product? What can you do if you have a log of a product? It would be the log of the first, log base b of the first, which would be x to the 4th. What's the key word? Plus. You have to add logarithms, right? Plus the log base b of z to the 9th. Okay? Now, is there something you can do with the log base b of x to the 4th? Bring the 4 down and make it what? All right, we'll make it, I'm running out of colors here. We'll make it 4 times the log base b of x, right? And what about this one up here? This 9 would be plus 9 times what? Log base b of z. Okay? And that's broken down. Any question on that? Other than why would I ever want to do this? Now, why would I ever want to do this? It's a very good question, but I can't answer that just now. We've got to get to the next section before I can show you why. I want you to be able to break things down into separate logarithms. And then after you learn to do that, guess what's the next thing we're going to need to do before we do anything else? Learn to put them back together. Okay? So I'd like to do a problem or two. Let's take another problem. Don't want to get lost in this. There are about 3 or 4 pages of practice, and it's going to be repetition and drill. It's just getting used to the properties. The only way I know to get used to something is to spend time with it. The only way you can learn this, make any sense of it, is to do a lot of problems that are very similar. So I've got a whole page full of problems there. Numbers 1 through 18 are all going to be using these properties of logarithms to break the logarithm down into separate logarithms. Now let me go on, because I'm running late. Let me run on to number 20, which is going to be a problem that goes in reverse. Number 20, the problem says 4 times the log base b of y plus 2 times the log base b of x. Okay? Now, instead of breaking it down, this one's already broken down. I want to put it back together. You see, if you can take this 4 and bring it down, you ought to be able to send it back, don't you think? In other words, work the property in reverse. What would be 4 log base b of y? Can we write that another way?
Log base b.
Log base b of y. Take the 4 back up. Make it y to the 4th, right? Okay? How about the next part? This will be plus. What about this part right here? What about this 2? Can we do anything with that 2? We can bring the 2 up to the exponent. See, if what I'm saying is if the exponent can be the coefficient, then the coefficient can be changed to the exponent. So that would be log base b of what? X to the 2nd, right? Now you've got a log plus a log. Now if you can take a log of a product and make it the sum of the logs, then you ought to be able to go backwards with it, right? And what can you do with the sum of the logs?
Log of b.
Make it the
Log base b.
log base b, okay? Log base b of the product, which would be y to the 4th times x to the 2nd. You see, and put it back together like that. All right? Yes.
Log base.
Log
Log base b.
log base b of this product.
Okay.
Okay? All right, now you've got a bunch of practice like that, and you'll probably have some questions on that. I'm not pretending to do this comprehensively. I'm just trying to give you the outline of it. There are going to be some details and some difficulties in these exercises. I've designed these exercises so they give you practice at these properties. Okay, today I'd like to talk about logarithms again. In case you're looking at this videotape, there is a Logarithms Part 1 in which we began an explanation of the definition of logarithms, and we talked about the calculation of the values of e to a power and the log of numbers and the ln of numbers. We've done that in the previous section, so you might want to look at videotape number 1, Logarithms Part 1, if you need that. And in that first video, I also began working with section 4.03 and 4.04 on the properties of logarithms and also on solving exponential equations. So as I go over this material, if it seems like it's repetitious, just put that video on fast forward and watch me fly through this material. Okay? Now, let me summarize the properties of logarithms as they were given on the first video. The first law, if you have the log base b of a product of logarithms. Now what would that be? This is law number 1. Log base b of mn. When you multiply, what do you do to the exponents or to the logarithms? You add exponents and you add logarithms. In other words, log base b of m plus the log base b of n. All right? Now, if when you multiply, you add exponents, what do you do when you divide? Log base b of m over n would be log base b of m, and then what? Minus the log base b of n. All right? The third law has to do with powers. And that would be like this, the log base b of, let's say, m raised to the n power. M raised to the n power, we learned in the previous explanation that what this means is you can take the exponent and it becomes the coefficient n times the log base b of m. Okay? And I presented that in a little more detail in the first part of this section. So I want to take those as the basic laws and continue with those. There are about 4 applications that I want to remind you of. And the applications are these, especially with regard to log base b of m to the n power. The specific applications are like this. First of all, if I had the log base b of the square root of x, can you write that square root of x as a power? What would it be? Log base b of x to the 1/2 power, which makes it 1/2. In other words, you could write that as 1/2 log base b of x. And in general, what if it's the, well, let me do another one. What if it's the cube root of x? The log, similarly, log base b of the cube root of x would be what? Log base b of x raised to the 1/3 power, which becomes 1/3 log base b of x. Okay? In general, let's just change this to the general case. The nth root of x would be x to the 1 over n power, which would make this 1 over n times the log base b of x. Those are a couple of specific applications of the third law. There's another law that I should mention, another application of that law that I should mention, and that is the log base b of 1 over x. Log base b of 1 over x, you could write that as a quotient, right? Since that's a quotient, you could write it as the log base b of what? Instead of writing it 1 over x, let's write it as x raised to a power -1, right? In other words, that would be, when you take that -1, that -1 would be -1 times the log base b of x. -1 times the log base b of x. All right? So another way to approach this, let me approach this last application, let me approach that in another way. What if I took the log base b of 1 over x and wrote it as a quotient and used the second law? Let's use the second law instead of the third law. What would that be? Log base b of 1, and then what? Minus the log base b of x. Now, is that the same as that?
Yes.
What about this log base b of 1? Do we know what the log base b of 1 is? We don't even know what b is. How can we tell what the log base b of 1 is? Well, let's suppose we don't know what it is. And in this case, maybe we're not supposing. Let's let it equal some unknown. Let's say y. Then what would you have? B to the y. Go back to the basic definition of logarithms, like we had in the first section. B to the y equals 1. B to what power equals 1?
0.
B to the 0 power is 1, right? So this whole thing has to be 0. If this is 0, then you get 0 minus log base b of x. So that's minus log base b of x, just like it was down there. Okay? So the result is negative log base b of x. All right? Any question on that application of it? All right. Now, the rest of this section 4.03 is just manipulative. It's trying to get you used to those laws of logarithms. There's only one way you can get used to something, and that's to spend time with it, and to practice it, and to do these things over and over again. These laws of logarithms probably are not natural to you. They are natural laws, but they're not natural to you until you spend some time with it. And I must say, over the years, they are becoming somewhat natural for me. I can almost think in logarithm. Almost. Okay? I'm working on it. But now, what I want to do is give you a chance to practice a few of these problems, because we are going to need them in the last two sections. The last two sections are where we have the applications of this. There are really two applications. One is the application of solving exponential equations. That's going to be 4.04. And then the last section that we'll do is the application of the growth and decay problems. That growth and decay problem, that's going to give you something to look forward to. That's what math is really good for. So when we get there, you'll be glad you know the laws of logarithms, because we use these laws all the time. All right? Let me clear this away. But remember them. I'm not wiping them off of your memory, am I? Just off of your screen. So if you don't have those written down somewhere in front of you, have them written down in front of you somewhere. All right? I'd like to begin with problem number 10 as an application of this. Number 10 in section 4.03. 4.03, number 10. And the problem says log base b of x y to the third divided by z squared. All right. Do you notice that there's a property of logarithms that applies to this? This is the log of a quotient, isn't it? So what can you do to a log of a quotient? You could split it up and make it subtraction, right? You could make this the log base b of xy cubed, that's the numerator part, and then minus, and then we can do the denominator part, which would be the log base b of z squared. Now you may wonder, why do I want to do this? Why would I want to? Is that simpler than this? I mean, this was a single logarithm, and now we're getting two different logarithms. Well, it doesn't simplify it. This is just an exercise to get you used to the laws of logarithms, and there are places later on where we need to have these skills. There are places later on where we need to have these skills. Now, can you see that this is a log of a product? So we can break it down some more, can't we? The log of a product, what would that be? All right, we could make this, instead of the log of a product, we'd make it the log base b of the first number, right? The first number, which would be, let's say, x, and then what? Plus, then we'll have plus the log base b of what? Of y to the third, all right? Y to the third. The log base b of y to the third. Okay? And then we still got this thing out here, don't we? Minus log base b of z squared. All right? Now, the third law of logarithms. Remember the third law of logarithms, where you have log of a number to a power. You can use that to bring the coefficient, to bring the exponent down to serve as the coefficient of the logarithm. In other words, what can we do? The first part, we just leave it alone, right? Log base b of x. And then we'll have what? Plus 3 times the log base b of y. And then what? Minus 2 times the log base b of z. Okay? Any question on that? All right? Now again, why would anybody want to do that? I just have to ask you to trust me for now, but there are reasons why we need to be able to do that later. For right now, all I'm going to say is we're taking a single logarithm and we're breaking it down. Now, if you can take a single logarithm and break it down, could you take separate logarithms and build it back?
Yes.
Right? How do you do that? You just take this tape and put it in reverse and watch me do it. All right? Isn't that right? That works. Right, now, I'm not going to run, I can't run the tape in reverse, so I'm going to have to do it myself. Let's take a problem like this and work it backwards. The first thing I would, in other words, let me give you the problem that it would be. Let's start over with it. With the problem that would be looking like this. Here is the problem. Log base b of x plus 3 log base b of y minus 2 log base b of z. And my problem here is to take this expression and write it as a single logarithm. Let's write this as a single logarithm. So what I can do first, I need to get log, just plain log. I don't want a number of logs, I want just log. So let's take this coefficient, and if you can bring the coefficient down, you can send the coefficient back up to the exponent, right? So in other words, what I'd have to do here is go like this, and go like this. I just put it in reverse. What do you have first? Log base b of x plus the log base b of what? Y cubed, okay? Right? And then I'll have minus, and this will be log base b of z squared. Okay? Log base b of z squared. Right? Now then, what you'll do with this, you'll have the log base b of x plus log base b of y cubed. What can you do with that? That's a product, isn't it? You could put that together and make it the log base b of, let's see, let me get this in yellow chalk so it'll stand out better. Okay? That'll be what? If it's log plus log, what we do is we pull it together and make it log of a product. See, we're having to work backwards on this from what we did before. So that's going to be x, y cubed, and then what? And then it's going to be all divided by, if you want to take this and pull it in with this part, since it's minus, it's going to be divided by, isn't it? Divided by, let me make that in yellow also, divided by what? Z squared. Okay? So in other words, this is what the problem was for number 10, isn't it? So we worked it backwards. Okay? Now those of you on the video that want to see this thing worked out again, just take this, what I just did, and run it in backwards, reverse. Okay? Never mind. Cut that out of the tape. Okay. Just kidding. All right.
The hard one to do with those is that number 25 on page 23.
Number 25 on page 23.
You're having to end up.
Okay. Number 25 on page 23.
And I think 31 is much better.
You think 31 is better?
Yeah.
Well,
Either one of those three
let's do
constants.
it. I want to look at 25, I think. Take a look at 25. Number 25, it says 3 log base b of x minus 1/2 log base b of y minus 2 log base b of z. And what I first need to do is translate these coefficients into exponents, don't I? So what would I write first? Log base b of x what?
X to the third.
To the third, okay? And then minus log base b of what? Square root of y, that is y to the 1/2 power, right? Which y to the 1/2 power means square root of y, okay? And then minus log base b of what? Z squared. All right? All right. Any question on that? Now, it turns out that if you have a log minus a log, and minus a log, and then plus a log, that the plus factor, the plus terms are always going to give you numerator factors, and the minus terms are going to give you denominator factors. That's the way it turns out. So what would you have for this? Log base b of what?
X to the third.
X to the third over. Now it's going to be over because this is subtraction. Square root of y. And this one will also be over what? Z squared. So in other words, these are going to be, because of the negative, they're going to be denominator factors. Okay? Now you can use that concept in number 31 also, or in the rest of them on that section. And I can look at number 34 and explain a major concept on number 34. Any question on this? Okay. In number 34, you have this problem. Log base b of b to the third. And let's pretend for just a minute that you don't know what it is. So what would you do? You could say equals x. And then what would you have? B to the 3, b to the x equals b to the 3, right? B to the x equals b to the 3. Let me write that down. B to the x equals b to the 3. And if the base numbers are the same and it's equal, what does that tell you about the exponents? They're equal. So x equals 3. Let me write this down again and maybe make a point here. Log base b of b to the 3 is equal to what? Log base b of b to the 3 is 3, right? Is 3. Log base b of b to the 3, the answer was x, right? X is 3. So the answer is 3. Now there's a major concept here. You'll see what it is. Log base b of b to a power is the power. Okay? In other words, what if I said log base b of b to the 7th? Anybody want to guess what that is? 7, right? The exponent is 7. What would be the log base b of b to the jump power? The answer would be jump, right? Okay? In other words, what I want to see about this is that the log base b of b to the x power is equal to x. And now we're in the Christmas season, right? And what happens at Christmas? Shopping, presents, wrapping presents, and guess what? Unwrapping presents. Now, if you wrap a present, the person you give it to has to unwrap the present. And that's exactly what I have here. You start with b to the x, and you start with x. X is like the present. Okay? And then b to the x is like you wrap the present. And you give it to somebody you love. And what are they going to do with that present? Unwrap it. And so in other words, log base b is the inverse operation of b to the power. Log base b is the inverse operation of b to the power. In other words, it's like wrapping and unwrapping presents. What do you end up with when you wrap and unwrap a present? The present. What do you do when you start with x and you wrap x and you unwrap it? You end up with x. What happens when you start with x and you take b to the x and then you log base b the x, the b to the x? Let me say that again. When you b to the x and then you log base b, the b to the x, it's like you unwrap the b to the power and you end up with just x. Okay? Now that's the same principle as this one. We talked about this last time, I think. Log base e of e to the x. What do you think that would be?
X.
the log base e of e to the x. Now you see it's the same base number. The base number of the exponent is the base number of the logarithm. That's what makes this work. Right? So if this is e, this has to be e also. By the way, if you had log base b of a to the x, you wouldn't have anything, right? Now what you could do with this, you could say x times the log base b of a. You could do that. I mean, you could do this thing that says equals x times the log base b of a, but we really don't know what the log base b of a is. We'll get to that in a little bit also today. But now, if I have the log, in other words, this answer would be x. Another way to write this exact same thing would be to say that the ln of e to the x. What's the ln of e to the x? X. You see that the ln is the inverse operation of e to the power. So ln undoes, or it neutralizes e to the power, and you're left with just the power. You see that? That's such an important concept. What if I took 10, the log base 10 of 10 to the x? What would it be? X. Now let me turn this around and do it another way. What if I said e raised to the ln of x? You see that if the ln undoes e to the x, what do you think e to a power does to ln of x? It undoes it, doesn't it? And you're left with, guess what? X. Okay? Any question on that? X.
So if we did ln of 1.
Right? Let me try
1
that.
in there.
The ln of 1?
Yeah, so if you said 1
What if I took
of
the ln of...
and then...
All right, ln of 1.
Okay.
Ln of 1 is what? Ln of 1. 0. Now put 1 in the calculator and push the ln button. That's all you got to do. You get 0. Now what if I do e raised to the 0 power? E to the 0 power would be 1, because any non-zero number to the 0 power is 1, right? So that would be equals to 1. So e to the ln of 1 is 1. Okay? E to the ln of x is x. All right? Any question on that? Okay? Okay, now, what was I doing here? Follow up with number 36, if you will. And let's see if we've got that concept down. Number 36, it says log base b of the cube root of b. What can you do with the cube root of b? Can you write that a certain way? Other than the way I've written it, log base b of what? B to the 1/3 power. Right? So what's the answer? 1/3. Log base b of b to the power is the power, right? So that would be 1/3. The answer is 1/3. Okay? Any question on that? Okay? Now, I'd like to continue with one more application. Let's look at number 60. And that will be the last one for this section. Then we'll talk about section 404. Number 60, and the problem number 60 says log base 3 of 27 times the square root of 2 over 5. All right? I'd like to kind of break this up, if I can, into separate logarithms. And just simplify it as much as I can. Now, if I can simplify something, that's fine. If I can't simplify it, that's fine also. All right, what do I have here? If I split this up into separate logarithms, what would you have? Log base 3 of 27 plus what? Log base 3 of 2 to the 1/2. Okay, let's go ahead and put that as 2 to the 1/2 power. Let's change that to yellow also so it'll look nice. And then what? Minus the log base 3 of 5. Okay? Log base 3 of 5. Now what? Is there anything you can do to simplify any of this? What is 27? Is that a special number to you? 3 to the 3 power. 3 to the third power. So this would be log base 3 of 3 to the third. You need to be looking for special numbers like that. 3 to the third, special powers, especially if it's log base 3. You see where I'm headed with this one? Right, then what? Plus, you'll have log base 3 of what? What can we do with this 1/2? I should have already did it, right?
Yes, it's already.
Bring down to 1/2, right? Sorry about
You
that.
should have done- Go ahead and bring it up.
Bring down to 1/2, we call it log base 3 of 2.
But then on the
Oh,
other
do I
one-
need to bring this 3 down?
Yes.
Do I? Or is there a better way? Log base 3 of 3 to the power is
3.
3 to the power. So you don't have to bring that in. But if you did, it would be 3 times 1, which is 3. So either way we do it, the next step, you're just one step ahead of me now. That's fine. Better to be one step ahead than one step behind, right? One step ahead of me would give you what here? 3. Just 3. Okay, now I've got to go finish this down here. This will be minus the log base 3 of 5. And then the final answer is going to be 3 here. And then plus 1/2 times the log base 3 of what? 2. And then minus the log base 3 of 5. Okay? Any question on that? Well, I got a question. What's the log base 3 of 5? Log base 3 of 5. Let me stop and make that one last. I said this was going to be the last question on this section, but it's not. There's one more. You don't usually have to calculate that. There's usually no point in calculating the log base 3 of 5, but I want to do it in this case just to maybe prove something or to get into something. We know how to find the log of 5, don't we? Log of 5. Everybody knows how to do log of 5? When I say log of 5, I mean log base 10 of 5.
Yeah.
You just take 5 in the calculator and push the log button, all right? Everybody in here knows how to find the ln of 5, right?
Yeah.
You just push the ln button. Well, do you have a button on your calculator for log base 3? Log base 3 of 5. You don't have anything like that on your calculator, do you? So what you'll have to do, you'll have to say, I don't know how to do that. Let's let it equal x. Let it equal x. Let that be the unknown, which at this point it is. It is the unknown. I don't have any idea what that is. Now, can you translate this over into exponential notation? 3 raised to the x power equals to 5. Now, the only problem here is that you have to solve an equation where there's an exponent in the equation, and you don't know what that is either. So did I really help anybody doing this? Well, actually, this is the bridge into section 4.04. Because in section 4.04, what we want to do is solve exponential equations.